Hello and welcome to my video on how to make graphs in Google Sheets. One of the more common things you'll have to do in physics is to take data, either collected from a lab experiment or given to you on our data table, or researched as we did today, and make it into a graph so we can start looking at trends and predictions. So the first thing you want to do is open up an untitled Google Sheet like I have here, and it's going to be blank, it's going to be relatively useless. Then what you want to do is you want to look at your two variables you're comparing. This can be anything from how far did something go, how long did it take, or someone's height, someone's weight, or in my case today I'm looking at the area of a country and its population. You'll notice right off the bat that my area doesn't fully fit. So if I double click here, like I did, it'll expand that out. So I have 5 countries right here. I picked 5, the first 5 that came to head, first being Russia, United States, Egypt, Australia, and then Argentina. So I go to the page, I go to the Wikipedia page, and it says that the area is 17 million, I can speak, 98,246 kilometers squared, or 6.6 million square miles. Either works, either is acceptable. Once I pick one, though, I need to stick with it. Now, in general, because this is a science class, I'm going to stick with the metric unit, which is kilometers. So I'm just going to copy this. Highlight, Control C, come over here to Chrome, Control V. Now, important thing to keep in mind. If you leave this unit here, the graph will not work. So what you need to do is delete the unit off of the number and then say kilometer squared up here. If you want to do superscript, it doesn't work particularly well in Sheets, but we know it's a kilometer squared. And then resize again. Population of Russia, 2020 estimate, puts it at 146 million. So again, copy, paste, and then repeat this process over and over again. Make sure you include your label on population, which is people. So United States, total area. Okay, notice how it says square miles and kilometers squared. I want to make sure I am being consistent. If I do square miles and then kilometers squared, it's not going to work out. So because I said kilometers squared the first time, I'm going to take this kilometers squared again. And then I'm going to take the population. Do the same for Egypt. Again, making sure I'm using the kilometers squared value. And then the population. And then do this 2 more times. Grab the population first this time, just because I can. And then Argentina. Now, suppose you want to label what these countries are, but we already put in all these numbers. We don't want to delete everything. Well, if you go up here and click on this right A, and then if you right-click, you can insert a column to the left, and you can add a new column, name of country. Not particularly useful for what we're ultimately going to end up doing, but a useful thing in case you make a mistake somewhere. Okay. Once you've got all your data in, you now need to make a graph. Highlight the numbers, and only the numbers, like so. Please make sure that there are no units in any of these boxes here. Again, it won't work if you have units. And notice how I'm leaving out the name of the country. Then you're going to come up here, go to Insert, and then Chart. It'll take a minute to think, and then congratulations, we have a chart. For us, however, especially in physics, we don't want a bar graph. What we wanted to do instead is come over here to Chart Type and find a scatter plot. Once you have a scatter plot, you're almost done. There are some other things that you need to include. First and foremost, you do need to have these axes labeled. Notice how, because I included the boxes at the top here, and here, they're already labeled on the axes. So the x-axis is area of the country in kilometers squared, which is exactly what I had here up in the top box. Here I have population of people and unit measurements of people. Now that we've made a graph, we want to be able to interpret, analyze, draw data and conclusions from it. For that, we need a trend line. So if you come up here and click Edit Chart, or go to the chart you had originally, you can go over here to Customize. So just 3 dots in the top right corner, Customize. You can change your style, your axis titles, in case you need to fix things. Every chart or graph that you provide or make for me should have a title describing what's going on. If you need to change the axis titles, just go to this little drop-down menu, vertical axis title, let you change it here. Alternatively, you can just click on the page and edit it there directly. Either way works. But the important thing is this Series tab. So let's go ahead and slide this over so we can see what's going on at the same time.
Now let's go down to the series section, and I'll start by turning off the video here so you can see what's going on. Under chart and axis title, just close it up and then go down to series. Whenever you make a graph for physics, you need to have a trend line. So you scroll down through series, and at the very bottom you see a little box labeled trend line. Clicking on it, put this line of best fit. It's an average of drawing a line through as many data points as possible, or as close to the data points as possible, averaging the distance between the point and the line to give the minimum distance. It's called the line of best fit or trend line. Once you have a trend line, you also need to include an equation, which is under the label, use equation, and an r squared value. The equation gives us a prediction, an idea of how this works. The r squared we'll talk about more later. For now, just need to know where to find them. We'll talk about interpreting them in a future lesson. And that's all you need.
Go through, add all this to your graph. If you've got all that done, once you've made your graph, it looks like this. You should have several of these key points. You should have a title. You should have data with axis labels.
With units.
X label, Y label. You should have at least 5 data points. If you didn't highlight all your data or you made a mistake somewhere, you might only have 4 or 6. 6 is okay, 4 is not. You want to have at least 5. If you want to have 15 data points, be my guest. But at minimum 5 for any lab we do, any data collection we do, any example. A trend line, r squared equation, that's everything, provided I didn't repeat myself 7 times. And that's all you need for one of these assignments. Go ahead and give it a try with your own data. Please feel free to ask questions if you need any help.